Hi, I'm Herb Gross, and welcome once again to our Math as a Second Language seminar. And today we're going to be discussing adding signed numbers. And again, doing this from a purely formal definitive style, it sometimes causes a problem. For example, let's look at, say, positive 5 plus negative 3 from a profit and loss point of view. You have a $5 profit followed by a $3 loss. The end result, the net result, is a $2 profit. Well, the person says, I understand that, but how can you call that adding when you subtracted the 3 from the 5? No, I subtracted the adjective part of negative 3 from the adjective part of positive 5. But I didn't subtract negative 3 from positive 5. In other words, it becomes a little bit tricky using the words addition when you're really taking away. Sort of in the same way, when you said to divide, you invert and multiply. People say, how can you call it division if you're multiplying? So I want to just gradually show how that evolves from our adjective-noun theme and from just the rules of math, okay? So let me start with a relatively simple example. Remember, up until the time that signed numbers were invented, we didn't talk about positive 2 and positive 3. We just talked about 2 and 3. It was only after we introduced signed numbers that we changed the name of 2 to positive 2 so that we could now distinguish it from negative 2. Remember that up until signed numbers were invented, there were no numbers to the left of 0 on the number line. So the fact that 3 plus 2 equals 5 is simply another way of saying positive 3 plus positive 2 equals positive 5. And if you're using the profit and loss model, a $3 profit followed by a $2 profit is a $5 profit. Now we want to do this in terms of the adjective-noun theme, so what we're going to do is we're going to still use the words positive and negative, okay? But we're going to spell them out and write them after the adjective, so it looks more like the adjective-noun format. In other words, instead of writing, say, positive 3, we'll simply cross out the positive sign and write out the word. Now, the reason I do this, remember I said, if you understand the adjective-noun theme, every arithmetic problem using numbers, okay, can be done just knowing whole number arithmetic. So look at 3 positive plus 2 positive. What are the 3 and 2 doing here? They're modifying positive, okay? 3 plus 2 is 5 whenever 3, 2, and 5 modify the same noun. So according to that rule that we learned way back early in our course, 3 positive plus 2 positive is 5 positive, okay? In a similar way, negative 3 plus negative 2, that says what? 3 negative plus 2 negative. Notice the 3 and the 2 haven't changed here. It's only the noun that has changed. Be very careful here. The 3 in negative 3 means the same thing as the 3 in positive 3. It's the positive sign and the negative sign that tell you what they modify. So 3 negative plus 2 negative is 5 negative, and that follows very easily in terms of a $3 loss followed by a $2 loss results in a loss of $5. The trouble that comes up is, what happens if we have negative 8 plus positive 5, and we want to use the adjective-noun theme here? That's a little bit tough, because you see what happens now. The 8 is modifying negative, the 5 is modifying positive. When is 8 plus 5 13? Only when 8, 5, and 13 are modifying the same noun. Why can't we add the 8 and the 5 here? Because they're not modifying the same noun. So again, for motivation, let's see how we would handle this in terms of profit and loss. Well, maybe you would do something like this. Here's an $8 loss, here's a $5 profit. By the way, do you notice that there are just no signed numbers here? The signs are up here. By putting the 8 in the loss column, it now represents negative 8. By putting the 5 in the profit column, this now represents, it represents positive. Again, what would you usually do here? Sometimes a person would just automatically say, well, I'll take away the 5 from the 8, so the net result is a $3 loss. The problem is, how would we say this using only our rules? Is there a way of rewriting this that would suggest where negative numbers would come in? Well, let's do it this way. If instead of being an 8, this had been a 5, wouldn't this be a pretty easy problem to do? A $5 profit followed by a $5 loss would simply be 0. So what we do is, let's take the $8 loss, okay? Think of the 8 as 3 plus 5, and we'll break down the $8 loss into a $3 loss plus a $5 loss. In other words, doesn't this still say there's an $8 loss? The difference now is that we can see just by looking that the $5 profit and the $5 loss cancel each other, and all that's left is the $3 loss. We can say as a shortcut, rather than to write this way, let's just subtract the smaller adjective from the greater. See, these are positive numbers. Subtract, and we're always subtracting the smaller one from the greater. Subtract the smaller from the greater. Well, 5 from 8 is 3, and put the answer in the column in which the greater adjective appears. Well, that's the 8. In other words, this is a shortcut, if you want to call it that, of having done it this way. So why did I do it this way? The reason is I now want to show how we can adapt this so that we don't use any words at all. Remember, that's what mathematics is. It's a language without nouns. And unless we can visualize the nouns in our own mind, this simply becomes like a foreign language, which if you're lucky, the student will remember it long enough to pass the test. But if we define education to mean what's left when you've forgotten everything else that you've been taught, the student hasn't really been educated. So let's take a look and see how we can do this. We look at -8 plus +5, and we say, gee, if this had been -5 instead of -8, the answer would just be 0. So what we say is, good. What we'll do is we'll write the -8 as -3 plus -5. See, the motivating force is, why did we break the 8 down into a 3 and a 5? The motivating force behind this was that the number we were adding to it had an adjective value of 5. It was +5, so we wanted a -5. Why did we want -5 here? Because once we break it down this way, and by the way, just check, -3 plus -5, $3 loss followed by a $5 loss is still an $8 loss. Okay, so we still have that okay. Now by the associative property, I can regroup the parentheses here so that they enclose the -5 and the +5. Now I invoke the rule of the additive inverse, the opposite rule, that a -5 plus +5 is 0. -3 plus 0, what's the 0 property? It doesn't change anything when you add it to a number. That's why it's called the additive identity. So -3 plus 0 is -3. And now what I've done is I've translated the profit and loss model into an exact mathematical sequence of steps, each of which is justified by a rule of the game, a property that we've associated with numbers. And now this applies for anything in the whole world for which we want to use increasing and decreasing, or whatever model it is that obeys the rules that we've accepted as being the rules of the game, so to speak. So now it's very easy. If all I wanted to do was to teach this topic mechanically, after all this is said and done, what is the brief summary? To add two signed numbers, we break it down into two cases. If the numbers have the same sign, add the two magnitudes and keep the common sign. And I can see students saying, why didn't he say that in the first place? Well, because you may memorize that mechanically and then use it in the wrong place, where the rule doesn't apply. We'll talk more about that as we go along. We also have PowerPoint, animated PowerPoints that augment what we're doing in the videos, that go into some of the stuff more computationally and in more detail. But let's go on with this. The second case is what? The two numbers have different signs. And by the way, this is purely a case 1 and case 2. There's only two possibilities when you're dealing with two signed numbers. They either have the same sign or they have opposite signs. I don't know if you really appreciate the beauty of knowing that there are only two nouns. See, if there are only two nouns, as soon as I know it can't be one, it has to be the other. See, in other words, if I say I'm thinking of a number and it's not 8, well, it doesn't give you much of a hint. There are lots of other numbers. If I say to you, I'm thinking of a number, it's not positive, what's its sign? Has to be negative, because that's the only choice. Not positive means the same thing as negative, except in that special case of 0, which we treat as neither positive nor negative. It's the dividing point, okay? So what does case 2 say? The numbers have different signs. In that case, subtract the lesser magnitude from the greater, and notice that the magnitudes are always positive numbers, so you're always subtracting the smaller from the greater, but you keep the sign of the number that has the greater magnitude. So if we want to summarize this briefly, if you're adding positive 8 and positive 5, the numbers have the same sign, right? So you simply add the magnitudes, that's the 8 plus 5, and keep the common sign. I just separated this way so you could see it. See, in other words, I'm adding the 8 plus the 5, then keeping the common sign. So positive 8 plus positive 5 is positive 13. Negative 8 plus negative 5, again, the numbers have the same sign, so you add the magnitudes, 8 and 5, keep the common sign, which is negative. So negative 8 plus negative 5 is negative 13. Positive 8 plus negative 5, they have different signs. So what do? We subtract the smaller magnitude from the greater. The smaller magnitude is 5, the greater one is 8, so we subtract the 5 from the 8, and we keep the sign of the number that had the greater magnitude. The 8 was greater than 5, its sign was positive, so the answer is positive. And again, in your mind, if this gives you a problem, by knowing a background of this, in your mind you're saying what? An $8 profit followed by a $5 loss is a $3 profit. Here's the same situation, only with the signs reversed. They're still not the same sign. So what do? We still subtract the lesser magnitude from the greater one, same as we did up here. It's still 8 minus 5, but this time the greater magnitude is modifying negative, so the answer is negative 3. And again, you would understand this by saying, if I have an $8 loss and it's followed by a $5 profit, the net result is a $3 loss. I think this is about as simple as I can make it, and I think you can begin to see that adding sign numbers is not that strange, especially if you're thinking that adding now means, if you're thinking of the profit and loss model, if you're thinking of a transaction followed by another transaction, forgetting about whether the transactions are profits or losses. And in terms of sign numbers, you can always write the greater magnitude as the sum of two magnitudes. In other words, if you're comparing 11 and 5 and say they have different signs, you can always write the 11 as 6 plus 5, so the 5 in the 11 matches the 5 in the other number, etc. This is just the only thing you have to consider. So I think it's a good place now to come to our practice problem. And just, I think what I'm going to do this time is something slightly different. I don't know if I've done this before, but what I'd like to do this time is to give you a problem that practices what we did today, but at the same time will lead in to our next presentation, which talks about subtracting sign numbers, okay? So here's the practice problem. In the following addition problem, what number is represented by the blank in order to obtain the given sum? Negative 12 plus positive 8 plus negative 3 plus negative 2 plus positive 6 plus blank equals positive 4. What I want you to do is to pause the video, work on this problem. When you have the answer, or whenever you wish, resume watching the video and watch my solution and my comments on it, okay? Okay, so let's look at the solution to the problem. If you feel comfortable with understanding, say in terms of the profit and loss model, that the order in which the transactions take place is irrelevant, the fancy way of saying that is that the arithmetic of numbers, so far as we've defined them, is associative and commutative. We can change the order, we can add them in any order that we want, we can group them in any order that we want. All you have to say is what? Here's a $12 loss followed by an $8 profit. Okay, that's a $4 loss so far. Now I lose $3 more, that's a $7 loss. I lose $2 more, that's a $9 loss. I make $6, so I'm only down by $3. And now I have to know, what do I have to add on to a $3 loss to make a $4 profit, okay? And by the way, we could pause over here and see how you could do this just by what we talked about before. To get to a $4 profit from a $3 loss, is it fairly obvious that you first have to get a $3 profit? If I get a $3 profit, that will bring me back to 0, and then I need $4 more to make my $4 profit, so altogether I've had to do a $7 profit. And if this is too difficult or complicated or whatever you want to call it, to do a running total in your head, take your time and write it out. Any number that's modifying a negative, okay, goes into the loss column. If it's modifying positive, it goes into the profit column. So the negative 12, the negative 3, and the negative 2 all go into the loss column as 12, 3, and 2. The positive 8 and the positive 6 both go into the profit column. Now you just add them up. The total total profit was $14, or whatever units you're using. Total losses were 17. The difference between 14 and 17 is 3. The 17 is in the loss column. That's the greater magnitude. So you lost $3. And now altogether, you want to wind up making a total of $4. So is it kind of clear that the next transaction has to be, first of all, a $3 profit to get you back to 0, and then another $4 profit to get you to the $4 profit. And if you wanted to see this sort of spelled out, to see how you would do this, you have negative 3 plus positive 7. So what do you have to add on to the negative 3 over here? Negative 3, I'm just going to break the positive 7 down into positive 3 plus positive 4. I regroup, so the negative 3 plus the positive 3 add up to 0. Okay, 0 plus 4 is 4, and so that solves the problem, okay? Now, in summarizing what we did here, I want you to see that even though we think in terms of the adjective-noun theme, it's very, very natural, once we see a picture in our mind, to be able to go and to understand the formal recipe. In no way am I condemning the formal recipe. It's what I really want is for the student to internalize why that recipe works, so that, and to internalize it in such a way that years later they still remember it. See, the trouble with memorizing anything that you want to memorize is that once you get it mixed up, there's no way of getting it back again, okay? So anyway, I think that's enough for today's lesson. Next time we'll talk about how we subtract sign numbers, but until then, I just want to thank you for bearing with me. Hope you all study hard, have fun, and I'll look forward to seeing you next time.